Hi, today we will prove that sine alpha plus beta is equivalent to sine alpha times cosine beta plus cosine alpha times sine beta geometrically. We have already some drawings here, and if you wonder why our drawings is like this, first we have the lower triangle is with respect to the alpha angle, and cosine the second triangle, the above one, is with respect to cosine beta. And we choose this arrangement such that the alpha and beta are adjacent. So the total angle will be the alpha plus beta, the total angles. So which can be helpful in calculating the sine alpha plus beta. Now, we use the concept of unit circle here. That means the hypotenuse, or we are referring to AD and AC are unit length. That means AD and AC is both 1. So it's easier to deal with a unit circle. And if you remember, let's have a quick review. If this is theta and this is unit 1, with respect to the sine theta, the opposite will be the sine theta, and the adjacent is the cosine theta, of course. So that means if you have alpha here in the lower triangle, the length of BC will just be sine alpha, and of course the lower side will be cosine beta, cosine alpha, okay, using the unit length. So AC is 1. Now with respect to the beta, so this is another right triangle, so the length of DE will be sine beta. Okay, let me correct first. And the length of AE, so from this side will be cosine beta. So if A is cosine beta, that means AC, since the AC is 1, what's left is 1 minus cosine beta. Okay. So how to calculate the sine alpha and beta here? So we go back to our unit circle concept. So if you find the length, if you draw a line segment, so if you find the length of this side, we calculate the sine alpha plus beta, right? Because the alpha plus beta is referring to these angles. So if you find the length of this one, we solve our problem. Okay, now we will draw a horizontal line that kind of passes through E. So what we do is we draw a horizontal line that passing through here. Okay, passing through this point E. So this hidden line or this broken line will be parallel to the side AB. So if this is a parallel, that means if this is alpha, so this must also be alpha. And of course, by vertical angle theorem, this one must also be alpha. Okay, so now we have a right triangle. We have a right angle here. So if this is alpha, so this must be 90 minus alpha, right? Let me write clearly. Okay, so this is 90 minus alpha. Okay, anyway, so our length we partition into two parts. So we can calculate first the length of this one. So we can calculate the length of this one. We can label first this one as let's say x, right? So using the sine rule, we have sine of the 90 minus alpha is equivalent to the opposite, which is x, and the hypotenuse, which is the sine b. Okay, and if you remember, right, the sine of the 90 minus alpha is actually just the cosine of the alpha. Okay, we can write the sine 90 minus alpha as cosine alpha. Since x is the one we're looking for, we can just multiply sine b both sides. So we get x equals cosine alpha sine beta. And if you notice, this one is actually the first part of our expression in the right side, right? So we are already half done. So we found the length of this one. So we're missing the length of the second part, which is this length. Okay. So note, this one is sine A, right? And we can calculate the length of this piece by using again the sine rule. So we have sine alpha equivalent to, we can label this one as y first, right? So y over the hypotenuse, which is the 1 minus cosine beta. Okay. Then we multiply by 1 minus cosine beta, so y is equivalent to sine alpha. Okay, let's put in parentheses first. And if you distribute, we get sine alpha minus, okay, sine alpha cosine beta. Okay, since we are only interested at this length, which is the missing part, right? So we need to subtract sine beta as sine alpha minus the y value, right? The y value is this much. Okay, so if you distribute, pretty much this one cancel out, right? And negative times negative become positive. So this part, okay, this part become just sine alpha cosine beta. Okay, and this is the second part of our expression, which is the sine alpha cosine beta. And so the total length, we just add the x and the sine alpha and cosine beta. So our answer, almost there, which is the sine. We can write first the sine alpha cosine beta plus the x, which is cosine alpha sine beta. And we are done proving the famous identity sine alpha plus beta equivalent to this one. Okay, we can actually prove also cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta using same arrangement, but I think that would be in the following discussions.